we have one last conic section to look at, and these are called hyperbolas. A hyperbola does not look like an ellipse, but the definition of it is very similar to an ellipse. Remember that in an ellipse, it was the sum of the distances from the two foci is constant. Change that word sum to difference, and you have a hyperbola. So you choose two foci, and then a hyperbola is all of the points so that the difference between the distances to those 2 points is a constant. So in the equation for these, instead of seeing x squared plus y squared, we're going to see x squared minus y squared, or we'll see y squared minus x squared. One quick little fact to remember, I guess, is if our hyperbola is x squared minus y squared, that hyperbola is going to open out to the sides. So that's the shape of a hyperbola. It's kind of got two branches that go further and further out. If it's y squared minus x squared, then that one is going to open up and down. Graphing a hyperbola is actually going to be very similar to graphing an ellipse. We're going to just about do the exact same thing with a little bit of a difference towards the end. So we have x squared over 9 minus y squared over 4 equals 1. We're going to plot this almost exactly as if it was an ellipse. So if this were x squared plus a y squared, it would be an ellipse. We would have an x radius of 3 and a y radius of 2. Our center is at 0, 0. So we're actually going to pretty much start out with the same thing. We have an x radius of 3. So from our center at 0, 0, we're going to go out 3. So 3 to the right, 3 to the left. Our y radius is 2. So we're going to go up and down 2. Okay, it's x squared minus y squared, so we're going to be opening out to the sides like that. So we plot those almost as if it's an ellipse, but then here's where the difference is. Instead of drawing an ellipse, we're going to draw a box. And this is not part of our hyperbola, but draw a box around those, so a rectangle instead of an ellipse. Then, through each diagonal, from corner to corner, we're going to draw a dotted line through there. Do my best to make it dotted. And then I'll cross on the other diagonal as well. So dotted line from one side to the other. Those give us the asymptotes, the boundaries that the branches of our hyperbola are going to follow. So on this right side, our branches are going to go up and get closer and closer to that line. And as they go down, they're getting closer and closer to that line there. And then same on the left side. And we're going that way. So the pieces for us to report on this one are just the vertices. And in this case, our vertices are at plus or minus 3, 0. We don't have covertices. We could talk about those points that were up and down too, but those are not a part of the hyperbola, so we don't need to record those. The only other piece is the foci. Now for a hyperbola, the foci are somewhere out or like inside of the branches. They're in here somewhere. Okay. And it's similar for with an ellipse, except we're going to use c squared. So c is the distance to the foci is equal to a squared plus b squared. So that's actually just the Pythagorean theorem. All right. And in this case, it doesn't matter which one is a and b because we're going to add them. So c squared is equal to 9 plus 4. So the two were squared radiuses. So c squared equals 13. So c is a square root of 13, which would be 3 point something. But in this one, we could put that our foci are at plus or minus square root of 13, 0. So 3 point something. I'll put those just inside of 4 because I don't have a lot of room. would be our foci. So there's the graph, the vertices, and the foci. In our next example, we have y squared over 16 minus x squared over 25 equals 1. So this is y squared minus x squared. So that means this is going to open up and down. So let's get the points that help us draw that shape. So underneath our y is 16, so that means our y radius is 4. Under the x squared is a 25, so our x radius is 5. So from our center at 0, 0, because this one's not shifted anywhere, so our center is 0, 0. Our y radius is 4, so we go up and down 4. Our x radius is 5, so we go left and right 5. The next bit is to pretend that it's an ellipse, kind of. So we have those points like it's an ellipse, but instead of drawing our ellipse, draw the diagonal or the box around those points to help us get the asymptotes. So then from corner to corner, we draw the diagonals to get the asymptotes. So this one is much wider than the last one we just did. So there's our hyperbola. Our vertices are up and down this time. So our vertices are at 0 plus or minus 4. And then to find the foci, it's that distance c, where c squared equals a squared plus b squared, so 16 plus 25. 16 plus 25 is 41. So c is a square root of 41, which is going to be just more than 6. So our foci are at 0 plus or minus square root of 41, but that's going to be 6 point something. So we will plot our foci out there just past positive and negative 6. So last example here, this time we are moving our center. So we have x minus 2 squared over 9 minus y plus 3 squared over 9 equals 1. So it's x squared minus y squared. So we're going to be opening out to the left and to the right. Our center, so x minus 2 shifts us to the right 2. Y plus 3 moves us down 3. So our center is at 2, negative 3. So let's go ahead and plot that. And then underneath each of our x and y, we have 9, which means that our x and y radius are each 3. So from our center, I'm going to go right 3 and left 3. Oops. So left and right 3. Our y radius is also 3, so up and down 3. This would make it look like we're graphing a circle. That one was more than 3 there, wasn't it? 1, 2, 3. There we go. And that other one was more than 3. I can't count today. So up and down 3, 1, 2, 3. Okay. And then again, we make the box around those points to get our asymptote. This is opening to the left and right. So once we draw the asymptotes, this is opening to the left and right, so we have a branch opening out to the right, and a branch opening to the left. So now where are the vertices? So this time our vertices, if we look at our graph, are at 5, negative 3, and negative 1, negative 3. Then for our foci, c squared equals 9 plus 9. So that's going to be 18. And the square root of 18, that would be a 9 times 2, so 3 square root of 2, or approximately 4.2. So that means from our center we need to go left and right 4.2. So our center again is at 2, -3. So if we go right 4.2, that's going to put us at 6.2, -3. So take the 2 from our center and add 4.2, and then subtract 4.2. So adding 4.2 puts us at 6.2. If we subtract 4.2, that's going to put us at -2.2. So our other focus is at -2.2, -3. So plot those at 6.2, -2.2. There's our foci. So we've got our vertices, foci, and we have our parabola, or sorry, not parabola, hyperbola drawn.